Welcome my dear student. Myself, A. Griffin, Assistant Professor, Department of Mathematics, Sjctnc-Matlab-Unit. This is the video for MATLAB. It is an Unit 2 Part 4 video. In Part 1 video, we discussed about the mathematical operations in arrays. What is array addition, what is array subtraction, and what is array multiplication. In Part 2 video, we discussed about the array division, and Part 3 we discussed the element by element operation. In this video, we are going to see using arrays in MATLAB built-in math function. Already we seen in Unit 1 math built-in function. What is MATLAB math built-in function? For example, in C language, we know the keyword. Keyword is a fixed meaning, does not change anywhere in the program. So it's like that. MATLAB contains some mathematical keyword form, that is we call here built-in math function. For example, if you want to find the square root, we are using Sjctnc-Matlab. In this the same unit, first part we discussed an array addition, and we are using the I command EYE. This is also not a math built-in function. We are finding inverse in the third unit. Third part video, that is also one of the math built-in function. So it's like that. So we're going to see what are the built-in math functions in MATLAB using arrays. So in built-in function, the MATLAB are written such that when the argument, that is the input, is an array, the operation that is defined by the function is executed on each element of the array. One can think about the operation as element by element operation of the function. The result, that is output, from such an operation is an array in which each element is calculated by entering the corresponding element of the argument array into the function. For example, if a vector with 7 elements is substituted in the function cos x, the result is a vector with 7 elements in which each element is cosine of the corresponding element in x. So now we are going to see how to use this math built-in function. For example, we are having defined in such a way the x value. The x is valid from 0 to pi 3.1416 with 6 elements pi divided by 6. Now we are going to find the cos value y equal to cos x. So each x can be substituted. First x equal to 0, the value is 1. Next cos of 0.523x, the value is 0.860. Next cos of 1.0472, the value is 0.520. Similarly, every x value can be substituted. Otherwise, we can use the same another way. Suppose some matrix can be created, a 3 by 3 matrix. Using this matrix, we can find the square root. So the D matrix is equal to, we can use the first row 149, second row 16, 25, 36, and third row 49, 64, and 81. So now we're going to find the square root function. So Sjctnc, that Sjctnc is one of the math built-in function. So that is the square root of that function is 1, 4, 2, 3 first row, second 4, 5, 6, 7, third 7, 8, 9. So now we're going to verify this. It is in a MATLAB. Suppose if you open this MATLAB, the command window is like that. So now we're going to create a matrix D. So D equal to, it is a matrix first row 1, 4, 9, second row 16, 25, 36, third row, 49, 64, 81. So you close the bracket. So we having the matrix 1 for 3 by 3 matrix 1, 4, 9, 16, 25, 36, 49, 64, 8. So now we are going to find the square root. Let us choose another, we give another name C equal to Sjctnc of our prescribed matrix name is D. So we use D and to enter to get the result. So such a square root Sjctnc is a math built-in function. Here that math built-in function is applied for a array. Similarly, we can some different math built-in function we are having. The first one is mean. We know what is mean. Mean is an average. So like that, we are finding the mean of some arrays. Also, if A is a vector, returns the mean value of the element of the vector. For example, if you are taking A equal to 5, 9, 2, 4, the mean of A is 5. So add 4 element and divide with the 4. 5 plus 4, 5 plus 9 is 14, 14 plus 2 16, 16 plus 4 20. So 20 divided by 4 is 5. So mean is 5. Similarly, maximum. C equal to maximum of that array. So whole over this array displays the maximum value. Here we are taking the A value. A equal to 5, 9, 2, 4, 11, 6, 7, 11, 0, 1. So what is the maximum value? 11. Similarly, we can find close bracket D comma N equal to maximum of A. So it will reflect that A is a vector, D is the largest element of A, and N is the position of the element. The last one only will display what is the largest element. Here, D comma N equal to maximum of A means it will display that the maximum element as well as the position of the maximum element. So here the position of the maximum element is 1, 2, 3, 4, 5th place and as well as the 8th place. But here this display from left to right, what is the first nearest maximum place only it will be displayed. Now we'll see, for example, again we will find the maximum value of A here. So maximum of D having all the matrix. So to enter, so what is the maximum row? 49, 64, 81. So this is the maximum row. So of course you are having a 3 by 3 matrix. That's only. Suppose if you want a single row, for example, x equal to maximum of A. Again it will be maximum of D. So this is. So here if you want the maximum of x, you can display single element. And y equal to maximum of x. So maximum of x is 80. So the mean value. Mean of x. So mean of x is 64.267. So that mean, maximum, these are the math built-in function. So next one is the minimum. The minimum of the value. The same array having minimum is to display the minimum element. What is the minimum here? 2 is the minimum. Similarly, D comma N of minimum of A is the presence, the minimum element as well as the position of the minimum element. Here 2 is the minimum element. The position is 3, third place. Sum of A means we add all the elements of the corresponding array. Short of A means it will arrange in ascending order. Vector arrange the element vector in ascending order. Medium of A means it will find the medium of the corresponding rows. Similarly, we find another one, standard deviation of a the corresponding row. Determinant of a corresponding matrix. Dot product of any two vectors. If you are having two vectors A, B, A is the 1, 2, 3 vector, B is 3, 4, 5 vector. We are taking dot product in corresponding elements should be multiplied and then sum. Similarly, the cross product. The cross product means we are using IJK form. Here, there is no IJK will be displayed. The position of the coefficient only will be displayed. Similarly, we are finding the inverse. Inverse is already seen in the first unit and second part, first part also. So, many more places we have discussed about the inverse. So, are we going to verify that? For example, now clear the screen using CLC. So, now we use that A equal to 2, 3, 5. No need to display, so enter with sum. So what are this we are need? D comma n of, so closed bracket, D comma n bracket close equal to maximum of A. So A maximum value and position. So what is D? D is the maximum value, n is the position. What is maximum value? A? 5. What is the position? Third place. Similarly, now we are going to find a sum. SUM, sum of A. So sum of A we add. So 2 plus 3 plus 5. What is the value? 10. Similarly, we know another one is, what is the standard deviation? STD, standard deviation of A. Standard deviation is 1.5275. And another one is dot product. So we create another vector, B vector. B vector is equal to 2, 3, 6. No need to display, so enter with semicolon. So now we create the dot product of AB. Dot of within the bracket, the command is dot of within the bracket A comma B. So dot A comma B. So enter that, so we get the value 43. So similarly, we find the cross product, CRO plus within the bracket A comma B. We enter the, so value and standard deviation. So this is these are the math built-in functions in MATLAB. So next video we are going to see the next further problems in the second unit. Thank you.